Section 1.2.5 talks about intersection, union, and complement. These are operations that can be used to compare sets or to recombine sets, make new sets, things of that nature. Intersection is the first of these types. What intersection is if I have a list, A and B. What intersection will do is return members or elements that are in common between the two sets, so they should be in common. So if I were to look at A and B here, I can color code here and I can see both of them have hat and both of them have shoe. So A intersect B, that's how you would write this, would equal shoe, comma, hat. Now we could also write this using math symbols. I would have A with an upside down U, B. So this is A intersect B. This thing functions in a fashion that's similar to AND, and in fact its symbol is kind of similar to AND. The symbol for the AND is a V pointing up, and in this case it's a U pointing up instead. Union is something that provides members that are in either of the two sets. So if I were to dig through this set here, I know everything about B. I have this whole list, and I also have a list for A. The union of those would contain anything that's in either list, and none of them would be duplicated. They'll only be listed one time. So from the top, I would grab a sock and a shoe and a hat, and then I would get the shirt and the glove, but I already have shoe and hat, and so I wouldn't include those in there. This is written with a symbol with a U. If I write this mathematically, so this would be A union B. It's very similar to an OR for a logic operation. And if you think about the OR, it's also an upside down V. Well, it's not upside down V. It is a V. So it looks really similar to this U. The last operation introduced is complement. And complement is the members or elements that are not in a set. And generally speaking, this is going to reference the universal set. Okay, so I would have to have knowledge of what the universal set is. So in this case, I have a universal set. U is equal to sock, shoe, hat, glove, shirt, skirt, pants, coat. And I have A is the sock, hat, and shoe. I would write this as A complement, or I would write complement of A. You'll see it written either way. So A complement is going to be everything in U that is not included in A. So sock, hat, and shoe would be excluded, and A complement would be glove, shirt, skirt, pants, and coat. Now, you're not always given what the universal set is. So in a lot of cases, you'll have to construct what that universal set is or is known to be. So if I had three different sets, B, A, and C, and I want to find the complement of any of those, the first thing I need to do is build the universal set. And I'll build that by taking the union of A, B, and C together, finding anything in here that's unique. And I'm going to get skirt, pants, coat, sock, hat, shoe, glove, shirt from these lists up here. And then I can do A complement, like we've done before. And that's going to exclude anything that's in the list for A and return everything else to my answer for U. So skirt, pants, coat, glove, and shirt.